All right, for this next video, instead of writing on the notes packet, I need to show you how to type some things in your calculator. So I won't be writing on the notes packet, but we're going to start on page 67. We just finished the fundamental counting theorem, and now we're going to look at permutations and combinations. Permutations and combinations both tell us how many of an item, like the fundamental counting, but they're in different scenarios. So with permutations and combinations, both of them cannot repeat. So we're not drawing the same item. Once we draw something, we can't draw it again. So that's what separates them from that fundamental counting theorem. Now, the difference between permutations and combinations, they both can't repeat, but a permutation, the order that we're drawing it matters. So that kind of makes permutations a little special. They're not always, but there's sometimes some keywords. So you might want to add this to the notes on page 67. Some of the keywords that we see are the word ordered or arranged. That tells me that the order is important. You also can think about scheduling. If you have a class schedule where you have to attend a class at 8 a.m., if you show up in that room at 12, there's not going to be anyone there, or not your class. So schedules, the order also matters. Also, if we're thinking about phone numbers or IDs or names, the order matters on those. Think about typing in the passcode on your phone. If you go out of order, it's not going to unlock. You have to pass those 4 numbers in that exact order. So IDs, passwords, phone numbers, names, those orders all matter. And then the last one that kind of comes up is titles, like first place or second place, winning those awards, or maybe president and vice president. So getting a specific title like that. For all of those, the orders are going to matter, and it's going to be a permutation. Also on page 67, we have a combination. Combinations when order doesn't matter. They're not quite as special. I kind of like to think about it. I look at it and say, does order matter? If the answer is yes, it's a permutation. If it's not, it's a combination. Some things that are going to be combinations are where we're going to choose committees. So this past year, I was on a search committee here at Coastal. I don't know if I was the first person my chair asked to do that or the 4th person, but I know all 4 of us had to do the same amount of work. So it didn't matter what order he asked me to do it in. I was still on that committee and I did the same work. So committees are, the order doesn't matter. Also, the same thing with juries. Sometimes the problems will come up and say we're selecting a jury. The order doesn't matter on that either. You could be the first jury member selected or the 12th. You still have to sit there for the whole trial and be on the jury. And then most of the time, unless I say otherwise, when we're dealing with the lottery, picking lottery numbers, the order doesn't matter. As long as you have those numbers, it doesn't matter what order they're in, as long as I don't have a special thing on there. And the same thing with cards. If we're drawing cards, we're going to say the order doesn't matter unless I say otherwise. Sometimes I might say, and we have to pick them in that order. Then it would be a permutation. If I don't say that, it's going to be a combination. All right, let's practice typing these in our calculator. So on the next page, on page 68, we've got some at the top. Now there are formulas for these. So when you go to do the homework in My Math Lab, it's going to talk about this formula. Don't worry, we can type it in the calculator so we don't have to memorize the formula. So I'm going to start with the big calculator. If you've got a TI 83 or 84 or any variety of that, I'm going to start with this guy. So on page 68, we're going to type in that first example, example 7. We're going to start by typing in 11, exactly how we see it, so just the number 11. And then to get the permutation, we go to the math button, M-A-T-H, and we're going to arrow over to where it says probability. And on here we've got NPR and NCR. Those are our permutations and combinations. This one's a permutation, so I'm going to hit enter. And then the note said 3. So I've got 11, permutation 3. I'm going to hit enter and I get 990. Do the same thing with that smaller calculator. Now on the syllabus, we said to get an 83 or 84 or this 36X Pro. So I'm going to go over these. If you happen to have a different calculator, you can always go to YouTube, type in the name of your calculator, like 30X2S, and permutations, and you'll have some videos that come up. But these are the 2 I'm going to go over since these are the 2 that we said to get. So same thing, example 7A on page 68. I'm going to type in 11 again because we're starting with that. And this one actually is less steps. Right here in the middle, we've got a button that says NCR, NPR, and exclamation point. We're going to hit that, and we're going to have to keep hitting it until we cycle through and get the permutation. So 11P3 gives me that same 990. The other example is a combination. So go ahead, whichever calculator you have, try and type that in. You get the combination the same way you got the permutation. You're just going to get the C. So we'll do 11 combination 3. Go ahead and type that in. And you should get both calculators are going to give you 165 for that answer. There. You are always going to start with the largest number. If you don't, if for some reason you flipped the numbers, you're going to get the answer of 0. And none of these answers are 0. So we would know something went wrong with that. So both of them are going to give you that 0 answer, permutations and combinations. So you know you got it wrong, just flip those numbers around. All right, in the next video, we'll practice some of the problems that use these guys.